Today, I'll discuss about central limit theorem. Central limit theorem is one of the widely used method in statistics to test hypotheses. So, central limit theorem allows us to use the normal probability distribution to create confidence interval for the population mean and perform test of hypothesis. The central limit theorem states that the shape of the sampling distribution of the sample mean is close to the normal probability distribution. That means whenever you will have any population, it will definitely have any mean, and the sample mean of the sampling distribution will be close or equal to sample close to mean of population. So we can just go for an practical example here. This is the horizontal line, and we can draw our graph more simply. This is the graph, and we have this is the center. This is the center. For example, we have population mean is 28, and we have 3,000 samples. From this 3,000 population size is 3,000. From this population, we select 30 samples. That means X1 is our first sample, and the mean of that sample is, for example, 25. The second sample, X2, mean of this sample may be 29. And then we may have 3. The mean of the sample may be 27. Then we may have X2, and this may be equal to 28. That means mean of population will may be equal to 5. So it may be 26, something like that. 6. So these are something X, which is indefinite number of. So in that way we can move, and when we add all of these means and divide by the sample size, for example 20, 30, or 40, whatever the number we derive from is, if you take 30 sample for each sample, and then we take this mean of the sample, and for example 1, 2, 3, 4, we have 6 samples here, and we add all of the mean and divide by the 6, then whatever we get may or close to population. This is sample mean. We can that's right here. This is the summation of all. For example, 25 plus 29. So 29. It means we have this. These are the sample divided by, we have, for example, 6 samples. So we can divide it by 6. So whatever the result will be, it may be close or equal to 29. This is the basic of central limit theorem, and it normally used to test hypothesis that if you take a sample of 30 from anywhere, what is the probability that it may be equal to or close to or greater than 20? It will be tested using central limit theorem. So whatever the result will be, something like that. So now jump to a practical example. In graph, we have 28 years in BD to get a job. The average is to get a job for graduate student in 28 years in Bangladesh. If standard deviation is 4, what is more that a random selection of 35 students have an average age to get a job at or before 26, at or after 29, as we have mean is 28. So whatever the value taken higher than 28 will be at or after, and between 26 to 29 years. That means we will show everything here. So first of all, we have 28 is our population mean, that means mu, and we have standard deviation is equal to 4. So right now we have to go for our calculation. That means we have to find our z-score. Z-score equal to x bar minus mu. You can write mu in the form. So we have x bar divided by mu. Right now we'll have standard deviation. That means we use we can assign standard deviation here. This is standard deviation divided by root over x, so root over 9 n, small n, as we have sample size is 35 in our example. So we can write down everything here. N is 35 and standard deviation we have on x bar is x bar equal to x bar equal to 26 and 29. So we can write down here 26 and x bar 2 is 29. So we will have it is 1 x bar and it is 2. So right now x bar on, we can find that z-score for x bar 1. Now we can put the values here. And so values is 26 minus 28 divided by standard deviation value is 4. 4 you can write it in the form. So we will have 26 minus 28 by 4 root 35. 35 is our sample. So what will the value will be our z-score value for this sample size. So we'll have minus 2 . So our value will be equal to minus 1.35. 35 is our value. Who is equal to any of the value that we will go for the next part. So it is 26. So we can so 26 is here because below here, and then we have 29. Here 29. So 26 will be equal to, it is 26 and that is 29. These are the two values. So it's 1.34. Again, G score for Harmin, G score equal to then we'll have the standard deviation. And then n. N is same in both cases because we will take 35 sample. Then we have 29 minus 28 by, we have standard deviation value is 4 by root over n value is 35, so 35. So whatever the value will be our second G score value. So point so 1.479. 479. We may have some, we have some mistake here. So minus 2.958. So these are the two values here. So if we have a look at our GS value from the table, we see 2.958 will represent 2.958 equals to 2.958. Two point nine five eight will represent values 2.958. This is 295. 295 will represent 0.4984. 0.4984. So G score value will equal to 0.4984. You can write here value 0.4984, and the other values represent here will be 1.479, 1.47, 1.47, 4292, isn't 42.4292 is our second z-score value. So these are the two values here. So for the first requirement, we have what is the probability that student will get job at 26 or before that is probability we found here. Probability get job is this region. Probability get job here is at 26 or before 26. If we have a look at 29 or after 29, it is 42.92 or here. But if we have a look that if they will get the what is the probability of getting job between 26 to 29, in that case we have to subtract. So probability get job between 26 to 29 is 0.4984 minus 0.4292. So this is the probability of getting job. So our probability to get job is 0.4984 minus 0.4292. So our probability will be 0.0692. So our probability to get job between these two is 0.0692 or 6.992%. So these are our basic calculation regarding central limit theorem that is used to test our hypothesis that when how to be the probability to get some result. It may be used in marketing, sales, or packaging, etc. So that's all from today's class.